Storage Part 1. In this nugget, we take a look at storage, and this will be Part 1. If I can draw a line here, there we go, storage Part 1. We start off here talking about floppy disks and drives. Floppy disks are pretty close to obsolescence right now because they don't store very much. They're not very stable or reliable. They're much more subject to various types of damage than other storage media, but you may have customers that have old floppy drives on them, and they may have some data on old floppy disks that you need to be able to access. A better way to go, though, would be to use optical media instead. CDs and DVDs are much preferable to floppy disks and drives. And most computers nowadays have some kind of a CD or DVD reader or writer on them already. Also, flash memory is a very good way to go as well, and this is something that's particularly is overtaking any need that we had in the past for floppy disks, because although these generally store 1.44 megabytes, flash memory can store gigabytes worth of data, and it's a very convenient form factor as well. Can fit in your pocket, very easy to carry around. Also, solid-state drives are also a flash-based storage medium, and this is a very fast, high-performing kind of a drive that you can use in place of a mechanical drive, especially for situations where you need to be able to have very fast access to the main system drive. You know, isn't it something how storage has changed in the last few years? I remember my first hard drive was a 20 megabyte Seagate, and all of my friends said, "James, you're a fool. You'll never use half that storage space." Wow, were they ever wrong? I guess that's kind of like one of those old stories that us old folks tell to the younger folks. Like when parents tell their children, "Back when I went to school, I had to walk 10 miles to school, and it was through 2 feet of snow. It was uphill both ways." One of those kind of stories. But anyway, it really is something how storage has changed among other things. But one of the things that we still have to keep in mind is one of the old, antiquated methods of storage that sometimes you just can't get away from. That's right, floppy disks. Boy, are these things ever painful. Now, when it comes to these floppy disks, I almost misspoke myself horribly there. It reminds me, back when I used to work in an office building, I was part of a bowling team. And our bowling team was named, don't ask me why, the floppy disks. And then the secretary sent out an announcement via email about a bowling contest we had that was coming up, only she horribly misspelled the second word of this and left a letter out. Figure it out. So it kind of became an inter-office joke, which for some reason or other inevitably landed on me. I'm not quite sure why. But anyway, with our floppy disks, when you install them, they're going to be either drive A or drive B in most cases. Now, you can assign other letters if you want, but it's just kind of the conventional standard for them to be drive A or B. If you only have one floppy disk in the computer, or floppy drive in the computer, it would be drive A. If you have two, then it might be A and B. And then there were a couple of different sizes that we had. The older one was the 5 1/4 inch drive. Actually, it goes back even further than that. In decades past, there was actually an 8-inch drive, and I think there were even some other ones beyond that. But back in the early 80s or late 70s maybe, we had the 5 1/4 inch. But then any time where you have a modern PC, and I use modern very, very loosely with that term, then you would see a 3 1/2 inch floppy drive. That's probably going to be the focus on the A+ exam, is this form factor and this size. What we work with these drives and with these disks is that you will connect a 3 1/2 inch floppy drive using something called a Berg power connector. Let me see if I can find one. I think I got one right here. There it is. That's a Berg power connector. You can see it's got a little notch on it on one side over here so that you don't mix it up, and it's also got some notching over here, again, to prevent you from plugging it in, I don't know, upside down, backwards, sideways, whatever. Now, also, before I move on, I would like to point out that most drives nowadays are actually not going to be the old kind of floppy drives that we used to install. And these would be installed much like a hard drive is also installed. It would have 2 screws on each side of the drive, and then you would install it into the drive cage using 4 screws. Very, very simple. There's really not a whole lot to it. And then you would install it in one of the 3 1/2 inch drive cage slots that you might have. This would have to be an external drive that you would install. That way you would be able to access it from outside of the case, whereas hard drives and the like are normally installed internally because you don't usually need to touch them or access them for any reason. But what I'm trying to get to there is, nowadays most of these are USB drives. So that you just plug in an external USB floppy disk drive, and then you can kind of carry it around with you and plug it into any machine that you might need it to be connected to. Normally what we're going to use a floppy disk for these days is to just transport small amounts of data, such as a few sets of drivers or something like that, or very small utilities or something. These are largely falling out of favor in favor of USB flash drives or thumb drives instead, because they store much more data, they're much more durable and easier to transport, not quite as bulky. So these really are kind of going away. I'm actually still surprised that they're actually even on the A+ exam, but there they are. And then by way of example, here is a USB floppy drive, and you just plug this USB into the USB port on the computer. Plug and Play will detect it, and then you'll be able to plug in a floppy disk into this disk drive, and it will be, you know, recognizable and usable. I actually have one around the office here somewhere, but it's been so many years since I used it, I couldn't find it, so I had to go to the internet and grab a picture of one. Okay, also what we have here to keep in mind is that you're going to be having something called, well, it's a 34-pin ribbon cable. And what's significant about this is where pin 1 is. Let me show you what I mean. If we go to a ribbon cable diagram here, a photograph that I took, we see that this is actually a pretty good ribbon cable for a number of reasons. Number one, it's got a big picture of a floppy disk on here, so you know that it's used for that purpose, because these are actually a little bit narrower than a normal hard drive ribbon cable, which is a 40-pin. Also, the other reason is the pin 1 item, which I was talking about earlier. Notice this right here, that pink line on the last ribbon over here, last part of the ribbon. This designates pin 1, which makes it easy to properly orient this on the drive, because you don't want to plug this upside down. So that if this is supposed to go on pin 1 on the drive, but if it goes instead on the opposite end and you put it in upside down, then it could cause the hard drive light, or rather the floppy disk drive light, to come on and stay on. And sometimes it could also damage this. Actually, I've seen some get damaged. It's not supposed to. It's supposed to just not work properly. But I've seen some get damaged. Anyway, then you can see here, if you want to count them all, there's 34 pin positions in this thing. This is also a pretty good ribbon cable in the sense that it has a key right there that prevents you from installing it upside down or backwards, and then a keyed position right here. So there's a number of different things that would prevent you from installing this one backwards, and it's a pretty good cable. Now then you'll also have varying capacities for your floppy disks. The low density disks are capable of 360 kilobytes worth of storage, so that's certainly not very much by any standards. There's also the double density disks, which were a whopping improvement of 720 kilobytes on these media. And then you would have high density. These are the most common ones that we find in storage today. High density ones are capable of 1.44 megabytes, and that's mostly what you're going to see. There's also extended density, which is capable of 2.88 megabytes, but by the time these came out, other storage solutions were out instead, and so these never really caught on, even though you would think that they would be a better solution. You don't see many of those around. And then just briefly, I wanted to show you some photographs of the floppy disks. Notice that this one is actually one for Microsoft Windows 4 Workgroups. This is an older operating system. Look, the date on here, 1993. Actually, they're giving these things away now. You don't even have to buy Windows 4 Workgroups anymore. It's kind of defunct. And if you know where to look, you can actually download it for free. So if you want a free operating system from Microsoft, just wait until your infants are in college, and you can probably download it for free if you're willing to wait that long. Anyway, you can see that's a rigid plastic cover on the outside of this, and it has a shutter. These can be made of metal like this one is, or plastic. I prefer the plastic ones because sometimes these things can get bent, so I prefer plastic. Notice the designation as high density here. Oops, kind of zooming in and out here, but this is upside down right now, but you can see over here that if you were to turn your head upside down, everyone stand on your head right now. Let's all as a class just do it together. And then you can see that this is actually an HD over here. And then just briefly here, you can see that I've pulled the shutter over to the side, which exposes the media here. By the way, because this plastic is so thin and this media is pretty sensitive, it's actually more sensitive to a magnetic field. So you wouldn't usually want to put one of these on top of a CRT monitor, which has magnetism in it, or near computer speakers, which have magnets in them as well, or those magnetically tipped screwdrivers and things. Those could potentially affect this, although all of those resources I've just mentioned to you are unlikely to affect hard drives because they're much better shielded than something like this. Anyway, I pulled this to the side, which if you read A+ books and all of that, they'll always tell you should never ever do this unless you've got mad ninja A+ skills like I do, and then you can kind of take matters into your own hands. But kind of the reasons for that are obvious, because you can see that there's kind of some dust flecks on there. There's actually also a cloth that lines the inside of the floppy disk that kind of picks that up as it spins around, but nevertheless, you don't want to do that because it could expose it to some kind of hazard like that, or a static charge or something. Also, you can see over here that there's the the HD symbol that I was mentioning earlier. Now we're right side up and we can see it. Those of you that have been standing on your head this whole time, you may now turn around and sit in your chair, because now we can see the HD. Okay, let's also take a look at the back of the floppy drive and floppy disk, and you can see this is just a different one by a different color, as you can see. And here we have a plastic shutter, just another notation of that. And then we have the spindle here. The drive would actually insert into this and spin on that basis, on that axis. And then here we have something that's of importance as well. If you have a floppy disk that has important data on it, you don't ever want to delete or format that drive or something like that, format that disk, then you can take this tab, oops, well, I don't know what happened there, you can take this tab right here and you can flip it up. Just take your fingernail and flip it upwards, you know, like this, and then it would expose an empty square right here, and it'll look exactly like this side right here. Then what happens is the light shines up through inside the drive, and it will identify this because it can see the light on the other side as a read-only floppy disk, and it will not allow you to delete any data, format the drive, or otherwise lose any of the information on it. And as we move on to optical storage, you're probably already familiar with these. These are the shiny media that you can buy. You know, it's a DVD, or maybe it's got a movie on it, or a CD that you have play music on. Or you can also get DVDs or CDs that you burn your own data or music or movies onto, and so forth. So that's the optical storage. And if you ever have one of those that you messed up a burn and it didn't work out right or something like that, then that's what becomes eventually your drink coaster, which sits on your desk. So anyway, that's one of the main uses for optical storage. What happens with this, by the way, is that the data is actually recorded using something called pits and lands. So if we were to take a look at a sideways view, a profile of a DVD or a CD, so we're just looking at the thin edge right here, and if we were able to look at this through some microscopic method, for example, then you would see that it's actually got what we call pits and lands. Okay. So what we'd have here is there's actually different elevations on these manufactured ones that you buy that already have a movie on them or already have music on them. And the lands are the higher elevation, what we see like this, little plateaus that you see on there. I'll put L for lands. And then the pits would be the depression or the valley that you see right here. And the lands might be ones, for example, and the pits might be zeros, for example. And in binary computer communication, you need zeros and ones to eventually come up with meaningful information. And they would be able to determine that this scene right here is from the dodging bullets scene in The Matrix or something like that. See, I exactly duplicated that scene. Maybe some of you are smart enough to recognize that right off. Because the combinations of zeros and ones I put into there. Anyway, from the manufacturer, they're made that way, so there's a physical elevation difference in there. And then when they are read in a CD or a DVD player, then the laser will shine on this, and it's able to distinguish whether or not it is a higher elevation or a lower elevation, and tell it whether or not it's a 0 or a 1 correspondingly. Now, if you have a DVD DVD burner or a CD burner, you can't just make your own elevations in this. So what happens there is the laser will come down and it will burn a pit onto the disc, and it'll be a darker color. Here I'll have a really shiny laser on here. A fiery red laser comes down on here and it burns. I'm getting illustrative here. It burns a pit on here. And as a result, what happens when that occurs is that now when the reader reads from this, it interprets this darker space as a pit, and anything that doesn't have a darker space like this as a land. And so that's how you're able to kind of manufacture your own data on these RWs or these CDs or DVDs that you can burn yourselves. And again, of course, these are available as CDs. They're available as DVDs. They're available as read-only data or read-write data. If you use these in your burner and you're trying to write data to them, you can make it to a CDR, for example, or a DVD-R. This means you burn to it, but you cannot then erase that data and put other data on there in its place. With an RW, of course, you do have that capability. So that's just a little bit of the basic difference between those, and it's fairly obvious. Then we also have different speeds. For example, with a CD, you have 52x or 48x or something like that. And when you buy your media, it may say on there that it's capable of 48x speed. Well, what is x? 1x is equivalent to 153.6 kilobytes per second. Notice the capital B there. Now, we generally round that, so it's called just 150 kilobytes per second. So if I had a 52x, what would that be? Let me get out my handy little calculator here. Like this. Okay, so it would be 153.6 times 52 would equal, so that'd be like 7.9 megabytes per second. So that tells you what a 52x drive would be capable of, although most of the disks, it seems, are only 48x anyway. So that's what that one would be. Then we would have a DVD. Now, sometimes people look at DVDs and they say, man, DVDs are slow, because my DVD is only capable of 12x. Well, not necessarily. Look at that. A DVD's 1x speed is 1.385 megabytes per second. So if I had a 12x of that, let's go ahead and take a look at our handy calculator here again. That would be 1.385 times, and it would be 12x, instead of 7 megabytes per second, which you'd have 52x on a CD, that would be 16.62 megabytes per second. So it's more than twice as fast on 12x as a 52x CD would be. And then you will also have a couple of different formats that you can work with here as well. You might have, and you've probably seen this, CD minus R, or CD plus R, or DVD minus R, and DVD plus R, and then CD and DVD plus minus RW as well. So you'll see these two different formats. What's that about? This is the older format. Oh, I made a little smiley face there. Look, there's a happy little guy right there. Anyway, the minus is the older format, and it's broadly compatible, but it's generally not considered as quite as good as the plus format. And you kind of have to split hairs in order to be able to get to see the differences of those. But really, if we want to split hairs just briefly here, let's just say I'm looking at the edge of a CD or a DVD. And I know it's supposed to be like a semicircle here. And if you look at this microscopically, you would actually see these little grooves on the media, and it would kind of be in a jagged formation like this. Well, the minus uses a certain pattern for this to designate timing and some other standards that it has to identify on the disk. The plus uses a slightly different pattern. Here, I'll just do a different pattern. Okay, that's exactly what the plus pattern is right there. Anyway. It uses a slightly different standard. It's generally considered a little bit better than the minus. Now, overall, they're both still good, but if you have a really old CD or DVD drive or burner, then it may not be capable of reading the plus ones, and you might have to go to the minus media instead. But anything purchased at least since probably, 2001 or later is probably likely to be able to read plus, and so that's kind of generally what you'll tend to gravitate to. Now, there are a variety of different capacities as well for these type of media. For a CD, the older ones were capable of 650 megabytes worth of storage or 74 minutes. Now, why is there a correlation between storage and minutes? Because if you take a look at the disk, and this applies to both CDs and DVDs, they can spin at a constant speed. That's the center of the disk. And they go at a constant speed, and the laser is going to be able to read. Normally, they start from the inside, and they go out. And as it goes around and around and around, it'll take 74 minutes to go through every single track all the way around until it gets to the edge and finishes. Looks like I drew an onion or something there. I don't know. But anyway, you get the idea there. So that's why there's a correlation between space and minutes. Now, the ones that are newer will be at least 700, or will be 700 megabytes and correlate to 80 minutes round and round here. The DVDs, you'll have a single-sided DVD, which is the most common format that you'll see out there. It's 4.7 gigabytes and 4 hours to go all the way around the tracks out here. A double-sided DVD, and this is something that will have you'll have a single-sided media or double-sided. A lot of the movies that you'll buy nowadays, for example, on one side it might have widescreen, and on the other side it might have a standard format. So you can possibly have different kinds of media, different kind of content on both sides. You'll just pretty much double that. It'll be 9.4 gigabytes or 8 hours. Blu-ray discs are also single or double-sided. A single-sided is capable of 25 gigabytes in 11.5 hours. Double layer it would be a 50 gigabytes and 23 hours. Now also notice that it says double layer instead of double-sided there. With a Blu-ray disc, it's possible for, on that substrate, on that media here, for it to be able to have two different layers on the same side, and the laser is able to distinguish from one layer to the next, so you're effectively able to get double the storage on a single side. Next, let's go ahead and address something called flash memory. Now, this has a number of different form factors, a number of different purposes, but overall here, we should consider this persistent storage. This means that you can write data to it, and you can keep it there indefinitely until you decide to change it or you decide to format that storage media or whatever it is. It's also very fast, which also means that it's expensive. To be able to make it this fast in the manufacturing process and so forth, it is more expensive than something like hard drive storage or a DVD, for example. Also, flash memory has a relatively small form factor, and you'll notice this if you have digital cameras, and we've talked about that a little bit in the past. It'll have memory cards that you put in there, and some of them are no larger than maybe your thumbnail, very, very small. You may even have to put it inside of an adapter just so that you can make it large enough to handle. I work with compact flash cards, which are about, a little bit less than half the size of a credit card. So they're a little bit easier to manage. But there's a number of different form factors, though. Overall, they're generally considered pretty small. Also, the capacity varies with these. You can go generally between 256 megabytes, that would be a little bit of an older, for example, thumb drive, to storage media about 32 gigabytes. Some of them are going up to 128 gigabytes now for the larger USB flash drives, or thumb drives as we also call them. As I said, there's numerous form factors. There's SD or secure digital. There's compact flash. There's XD cards, and I'm not going to elaborate on all of those. It just depends upon who your digital camera manufacturer is. That's usually where most of these will go, is in digital cameras or in something like a smartphone or some kind of an MP3 player. Those types of devices are usually what accept these. And flash memory is what's used with USB flash drives. That's why they're called USB flash drives, or UFDs, as well, also known as thumb drives, for example, or memory on a stick. Some people will refer to these as well. And then, like I said before, they're generally going to be found, the form factor is generally going to be found as memory cards. And then here's just an example of that USB flash drive, or UFD. This is a 32 gigabyte flash Voyager, and if you look at it, it looks kind of wrecked here, doesn't it? That's because this eventually went bad. I think I accidentally bent it when I had it in the USB port. It was down kind of by my knees underneath my desk, and I think I accidentally bumped it with my knee and bent this thing all up. But anyway, from that point forward, it didn't seem to perform very reliably, so I just went ahead and trashed it. I took a box cutter and cut this thing open so you can kind of see what's inside of this, and you can get an idea. The storage is actually, all solid-state storage like this, not any moving parts or anything like that. The only thing you really have is there's a little light that will turn on here that you can see, and it'll shine through this little portion of the casing here when data is being accessed. You don't need to memorize anything about this picture in order to pass the A+ exam, but this is just kind of an example of what you might see in terms of the actual data storage itself for a USB flash drive. Now, one of the things that's actually pretty exciting in the world of storage is these new solid-state drives that have come out in the past few years. What these are is it's flash memory. It's flash-based data, or flash-based storage, and it's also going to be smaller than normal magnetic capacities like hard drives, is what I'm really thinking of particularly. At the time of this recording, hard drives are generally around 2 terabytes or more. But a solid-state drive is usually not that big. A solid-state drive is usually only going to be a few hundred gigabytes. Okay, so that's generally what you're going to see. For point of reference, I got a picture of one I grabbed here. This is a 120 gigabyte Western Digital one, for example. That's just this one's for a laptop, so you just plug it into your laptop. And the reason why you would want to use this, even though the storage capacity is smaller, is because it's flash-based. You don't have any moving parts. As a result, it could potentially be more reliable, although even flash memory eventually will kind of wear out. Even though there's no moving parts, it does have a lifetime. So that's something to keep in mind. But also, since there's no moving parts, it doesn't become the bottleneck in the system. Very often, in PCs anyway, the bottleneck for performance is going to be hard disk thrashing. So you're looking at the hard drive light, it just stays on constantly, and the machine seems to be running very slowly. Well, probably there's a lot of data that's trying to be written to or read from that hard drive. So since solid state doesn't have any moving parts, they're able to be much, much faster. These are also preferred for of the busy operating system partition or busy application drive, something like that, that would normally otherwise be more disk intensive, but for which you don't have huge storage requirements, such as for main data in a corporation or something like this. They're generally preferred for servers, again, for the operating system, maybe for the servers or for the applications, anything where you need to get a performance boost, but again, not for data. And then they're also preferred very often for power users who understand solid-state drives and want to use them instead of the mechanical devices. They're also very often preferred for laptops. In fact, some new laptops these days are shipping with solid-state drives, and although it's not part of the A+ exam, a lot of the Macintosh laptops will have solid-state drives. Now, in our next nugget, we're going to be discussing hard drives more in particular and the various interfaces that you can work with and so forth. But do also understand before we go on to that there are external drives you can also use. For example, we talked about CD and DVD drives earlier in this same nugget. Well, you can not only install those internally into an external drive bay, which would be a 5¼ inch drive bay, but you can also attach these externally, similar to what I showed you with an external floppy disk drive. Well, you can use an external USB drive as well. For example, this is an external DVD drive, and it just has a USB connector on one end of it, and you just plug it into whichever available USB port you have on your laptop or on your PC. So just be aware of the fact that these certainly do exist, and they're certainly available, not only for this type of media, CD, DVD, that sort of thing, but also for external hard drives. The external hard drives may come pre-packaged from a manufacturer, such as Western Digital. They have, for example, the Passport external hard drives, which do not even require additional power. They just use the USB power, and they seem to work just fine. But you may also need a more high-powered solution where you're using desktop hard drives on an external storage solution, and those usually will require additional power. And if that's the case, you might have something like this guy right here, and this is just got the cover removed off of this thing, but you can see that there's a fan over here, over on the left-hand side, right over in this area right here. My pen's kind of thin right there. Let me try it again. Like in this area, there's the fan, and then here would be your actual connectors. Okay, we'll talk more about these connectors in the next nugget, but this would be for the power for a serial ATA drive, and this would be the data 7-pin connector, 7-wire connector for the serial ATA drive. And then again, we may have seen these in a previous nugget as well, but that would be, for example, my power connection. I would just plug one end into this, and the other end into a standard 110 wall outlet. And then I would also have the external USB connector. There would be one end of the connector would go here, and the other would go, of course, to my PC. And then I would be able to access this drive as an external drive on my PC. And this kind of takes us back to where we were earlier, to this whiteboard, where I was mentioning the external drives. The hard drives, of course, are one of the external drives you can use. Then there's an issue of whether or not something is hot swappable. This means that you can plug it in, or more particularly, unplug a storage device without losing any data. Typically, if it is a FireWire device, or an IEEE 1394 specifically, or if it's a USB or an eSATA, okay, most of those are hot swappable. In terms of USB, this also would translate over to USB flash drives, or UFDs, as well. Examples of drives that would not be hot swappable are normally going to be internal IDE, technically they're enhanced IDE or eIDE, but they're generally internal IDE drives. Those are very often what the operating system itself is on and so forth, but they're usually not hot swappable, meaning that, again, they can't just unplug or plug them in without expecting some kind of an interruption to the operating system or the stability of the system, or without expecting to lose data. And then to illustrate these hot swappable devices, I've plugged in a USB flash drive here, which if we go to the computer, will be visible right here as a Kingston 32 gigabyte drive. And if I go to look around, I get some ebooks here, some pictures. Oh yeah. I was giving a seminar one time, and a friend of mine put up on the big screen in front of all these people this picture of me, where he pasted my picture on front of a monkey. Okay. Quite traumatic for me. It's taken years of therapy to get over, but to extend my pain, I decided to show it to you. Anyway, so I've got that drive there, and what I want to show you with that, let me go back to it, is that this will be a device that is hot swappable. But in addition to that, I also need to configure how I want it to be hot swappable. Do I want to just be able to pull it out whenever I want to, or do I want to have to send a notification first? And let me show you how you would determine that. If you go to Hardware and then go to whatever that device is, okay, and go to its properties, you'll see that there are policies here. Okay, and on this Policies tab, there's Optimized for Performance, which means that if data is being written to the drive, whatever type of drive it is, again, it can be USB, FireWire, USB flash drive, whatever, then the system may pause writing to that drive if it's busy doing something else first. In other words, it might be servicing a request of you as the user, or servicing a request from software or the operating system, something like that. And then when it gets a little bit less busy, it may then write to it. The problem is, if I'm unaware of that, I might just pull the drive out before it's had a chance to write that data. And if that's the case, the data may be corrupt or only partially written. Otherwise, you know, that's not a good thing. But the other thing I could choose is I could choose this top option, which is optimized for quick removal, and that would be the case if I don't want to use caching and I want write requests to go directly to that drive. Now notice that these are grayed out. That's partially a function of the fact that I'm using a virtual machine, which I talked about earlier, to demonstrate this to you, and it kind of locks down certain settings. Otherwise, I could just pick and choose back and forth between the two of those. But with Optimized for Performance selected, one of the things you want to be careful to do is if I decided to pull that out, and I wasn't sure if there was still data potentially being written to it, then I might want to safely remove it. In order to do that, I would close this up, and I would close any other applications that were using that drive. Otherwise, it won't let you do this. But I would then click down here, and it would say Safely Remove USB Mass Storage Device. I can click OK now. Notice that it says it can be safely removed. And then I would just unplug it, and I just unplugged it from the system here. And we'll go back into the computer, and we'll see that that is now gone. So that is how we can work with these hot swappable devices and how you can determine whether or not it's safe to remove them. In this nugget, we took a look at storage. This was part 1, where we started off by talking about floppy disks and floppy drives. These are kind of antiquated, as I mentioned a couple of times, because they don't store very much data, generally 1.44 megabytes worth of data. That's very much overtaken by other storage media that we have now. One of those, which would be optical media. That could be a CD or a DVD, and these store, 700 megabytes on a CD or 4.7 gigabytes on a DVD. Much better way to go, so we'd prefer those if we can. But another method that we can use to store data would be flash memory. This is going to be faster than any of these other methods that we see here, as well as the fact that it can store several gigabytes worth of data, and it's a very convenient form factor. We also have solid-state drives, which are very often nowadays used in laptops, for example, because laptops don't normally have the same storage requirements for data, so they don't need to be as large. And since they're not mechanical, they're able to stand up to shock better, which laptops are very often subject to, as well as the fact that solid-state drives are much, much faster than their mechanical counterparts. Well, I hope this has been informative for you, and I'd like to thank you for viewing.